In this video, we're going to look at the relationship that the inverse of a function has on an original function. So in the do now here, we have two functions, f of x and g of x. They are going to be known as inverses of each other. And let's see why. Take a minute and try A, B, and C of the do now. So pause the video and plug that in. Back. So in part A, you should have first plugged in 15 into the f of x function, and we would have gotten 39. Then we plugged 39 into g, and we end up with 15. In part B, same idea. We're plugging into f that -3. So wherever x was, -3 is going in. We end up with 3. And then we plug that number into the g of x function, exactly for where x is. And we end up with -3. For C, it's a little bit weird because we're plugging in x. So we're taking that f of x, which was 2x plus 9, and I'm plugging it into exactly where the x was of this g of x function. So I'm plugging into x, so I still have 2 of x plus 9, subtract 9 divided by 2, and it simplifies to x. So what you should notice for part D here is that every time we plug into both, it's like we undo what we just did in the first part. What appears to be true is that we always end up with what we originally plugged in. Okay, so that's what an inverse function will do. Anytime we have that, if we plug it in to both a function and its inverse, it's going to just undo what happened. So really, if we think about that a little further, inverses here, if I have a point, -3, 5, there's two major parts of a function. We have the x and y. So basically, the big idea of our inverse functions is to just switch at x and y. So if we want the inverse, it's going to be 5, -3. Okay. So we're taking the opposite. We're switching x and y anytime we want the inverse. And it does have its own function notation. It gets a little -1 up in the top. So function notation for an inverse is f to the -1 of x. So let's do a little bit more with that. Here we have the linear function f of x equals 2/3 x minus 2. And we have this graph, and we want to just evaluate where this notation is. So remember, if we plugged into regular function notation, it's always f of x. Kind of like we have right here. But if I was to plug into that, I'd be plugging in 2. But if I'm plugging into the inverse, I'm really looking at where we have 2 along the y. So this point here, that's going to be, that f inverse is going to be at 6. If I do that again for -4, we're looking, instead of the x, because we're switching x and y, we're going to be here at -3. Now, let's go a little bit further with that idea before we determine this y-intercept here. Think about each of these points that are on our graph. This point right here, that's the point 6, 2. If I switched x and y, that point's now going to become 2, 6. If I do it again for this point here, this point was originally 3, 0. So now it's going to be at 0, 3. This point, it was at 0, -2. So now we're at -2, 0. This point was at negative 3, negative 4. So now we're at negative 4, negative 3. And last point that we have on our graph here, we have this point negative 6, negative 6. So it's still going to stay right at that point. So this would be my new line. Basically, it's just from switching those points every time. So my x or my y-intercept that we're looking for in part D here, or part B, excuse me, is at 0, 3. Okay, which I could have gotten from taking the x-intercept and switching my points around, but we would get that new point in there because we're switching x and y every time. You might notice that we can always find these points too from geometry. This is a reflection over the line y equals x. Now let's look at it actually as if we have a function here. So we have the inverse of the function. We want to figure out what the original was in this case. But I'm going to rewrite this as y equals 2x plus 7 because we've talked about how function notation and equation are the same kind of thing. But remember, our big goal was to switch x and y, so that's exactly what I'm going to do. X equals 2y plus 7. Now to figure out what the original function was, we're just going to solve for y. So I'm going to subtract 7 from both sides. We get x minus 7 equals 2y. And then I'm going to divide both sides by 2. So we're looking at x minus 7 over 2. But remember, we were trying to find the original function, so I'm going to call this f of x. So I want to refrain from using y in this case. You would lose a point if you forgot to put it back into function notation. Let's do it again here. Now we have the original. We want the inverse. Works the same way. Y equals 5x all over 3x plus 1. Now we're switching x and y. So we're switching everywhere. So x equals 5y over 3y plus 1. So our goal somehow is to get y by itself. Remember, we can always stick this over 1, and we're going to cross multiply. And I'm going to have x times 3y plus 1 equal to 5y. Okay, we're going to remember to distribute. So we're going to get 3yx plus x equal to 5y. Now I'm going to move y over so it's on the same side. So I'm going to subtract that 3yx. So I'm looking at x equals 5y minus 3yx. Now remember, our goal is to get y out. I'm trying to get y by itself. So what I'm going to do is I'm going to pull the y out from both of them. So here I'm going to have x is equal to, let's pull y out, 5 minus 3x. And now that I have y by itself, I can just divide both sides by that, 5 minus 3x. And that's going to be x over 5 minus 3x equal to y. And to finish it off, though, remember we don't want to leave it as y. We want to make sure it's in inverse notation. Okay? So basically this, as annoying as that really was, it's just to rewrite it. So you're just doing whatever you can to isolate that y value. Okay? We got one more left for today. Same idea though. Y equals x subtract 3 to the third plus 1. We're trying to find the inverse, but we're switching x and y. So think the first thing to do to get y by itself is subtract 1 from both sides. We're looking at x minus 1 equals y minus 3 to the third. I think we know how to get rid of something to the third power. We're going to take the cubed root of both sides. So when I rewrite that, we're looking at the cubed root of x subtract 1, that whole thing is underneath, equals y minus 3. And then we just have to add the 3 to both sides. So cube root x minus 1, notice the 3 is outside of the radical. It happened after. And I can write equal to y, or I can skip right into that inverse.